Hi guys, and welcome back to Wade's Workshop. So, I think in this episode we're going to get on and make the flywheel for the engine, for the Webster engine. Since I spoke to you last, a parcel has arrived from Matt's. Hiya Matt's. I did expect a parcel, I knew it was coming. And Matt's has got me some brand spanking new centre drills. So, and those are the sizes I use most regularly as well. So thank you so much for those, Matt's. And a couple of spotting drills as well. I think an M8 and an M6 spotting drill. So those are great too. I have got some spotting drills. I know my M8's had a lot of use, so that's brilliant. Yeah, I know I can sharpen them, but yeah, it's quite difficult to sharpen a spotting drill. Now my eyes aren't as good as they used to be, so I do struggle with sharpening drills by hand nowadays. And also in the parcel was a really nice chunky piece of hexagon brass, probably, I don't know, 1.25 inches across the flats, and a slug off the end as well. So that's great. That's, you know, bits of material like this, it'll go in a drawer. I may end up needing a piece of, you know, inch diameter brass. I may need hexagon, who knows, going forwards, but always useful stuff to have. So Matt, thank you so much for that. So let's move on and go to the lathe and get this flywheel made then, shall we? I'm going handheld on the camera here. I want to rough out my flywheel. So we talked about this lump of cast iron at an earlier stage. You can see I've just faced the front. So to get it safely in my 3-jaw and to avoid putting it on a faceplate, which is, you know, I would have had to machine some sort of shoulder, it was too large in diameter to fit the 3-jaw chuck. So as you can see, what I did was put it up in the mill, and I machined 3 flats at 120 degrees to each other, just to get it to a point where I could reduce the jaws in so that they were well contained within the 3-jaw, and it wasn't I wasn't right on the end of the scroll, as it were. So yeah, basically just machine those 3 flats, tap the front square, and I've just done a sort of 1/2 mil facing cut on the part. So I think I'll just skim the OD. Now I'm going to leave everything here, maybe, I don't know, 1 millimetre 40 thou over size, as a starting point. So it's just very much just roughing down. So this cast is behaving itself quite nicely. The skin doesn't seem to be too bad. I've put a 12 thou cut on from the first touch. We've probably cleaned up just over half of the way round. Yeah, a bit of an intermittent cut on that little tip, but it's all good. Now the diameter of the part will pass under the bed, or the bed will pass under it, as you can see down here, so that's good. Checked all that out first. I've set a stop on my carriage, so that I can't feed so far in as I'm going to hit the jaws. So basically just running it nice and gentle, power feed, and when I get somewhere near my stop, I'll just drop the power feed off and hand wind the last bit. That'll give me a regular shoulder. So OD of the flywheel 3.750 when it's finished. So I'm going to be machining the OD to 3.8 inches. So just about there, knock that feed off. That's up against my stop. No idea what diameter I am, but I know I've got plenty. Let's go another 0.3. Let's see how this behaves. Might even clean up now. Oh, let's have a quick look at it. 2 chunks of missing area, missing through here and missing here. Cleaned up all the way around there. Okay, I reckon another 0.3 should do it. Feed back on. What am I running at? 220 RPM. Nice fine feed. That sounds more like cleaned up. So yeah, I'm going to rip it out to size. A couple of caliper measurements, I think, to get it to 3.8. No point in getting accurate at this stage. Not the finest finish, but 25 thou passes, taking 50 thou off the diameter. This should bring it down to 4 inches. So yeah, just keep going until we get to 3.8. So I'm down to the last 20 thou to come off. I've just sped the RPM up. Does it show? I'm up to 582. I was running about 300 before. Slowed the feed down, and that's a 5 thou side cut. I'm just experimenting to just see where the finish comes out. As my roughing sort of finish, that would be absolutely fine. So I've got my speeds and feeds sorted for when I drop it down to the 3.8. So finishing cut, 5 thou pass, and that should bring me to my 3.8. I've sped it up a little bit more. We're doing 650 RPM now, you know, on a 3.9 diameter for this little lathe. Seems to be behaving all right. I've got a reasonable finish. You know, it's not perfect, but this again, as I said, there's 50 thou left on the OD yet, so that's anti-dory. I think, as it stands at that diameter, it would fit the other way round in the chuck. So I think what I'm going to do after this is take it out, flip it 180 in the chuck. I'll just put a little chamfer on this top corner before I do that. Flip it 180 in the chuck. Yeah, I'm below the size of the 3 flats I put on there with this diameter, so I will flip it, and then we'll start from the other side then, rough that down, get the diameter down, get the shoulders on, that sort of thing. I will take you along the journey. Now, one thing I am going to say is that I am modifying this engine quite heavily in the area of the camshaft, the gearing and the camshaft. I've decided that I'm going to fit timing pulleys and a timing belt, just to mix it up a little bit. Obviously I've got the principle of how it all should work in my head, so I'm going to come away from the drawing quite a bit. So that means that I can change the flywheel design. Now the flywheel design shows, that should be finished diameter, we'll just check that. The flywheel design shows that the timing gear is sort of press-fitted and Loctited into the flywheel. 37.99. Okay, don't know whether that shows up, I'm sure you guys can see it. 37.99. So we're going to call that 37.99, 3.799 inches. Let me turn my power feed off. So yeah, I am going to change it considerably, which means it does allow me to simplify the flywheel a fair bit, because I'm going to have my timing pulley fixed on the crankshaft independently of the flywheel, which takes a lot of the accuracy needed even to locate the flywheel onto the crankshaft, or the main shaft. Takes out any accuracy in the position of the flywheel, and I'm going to have an adjustable position for the timing belt, or the timing belt pulley, which is also going to go onto the same shaft and get located via a clamp screw that can rotate, so that I can adjust timing. That's for many videos in the future, but I'm just planning ahead for that now. So anyway, that looks rather nice. I'm going to just put a chamfer on there. In fact, I have got muck everywhere here. 2 seconds. I think I hadn't noticed is my little adjustment screw is loose on that tool. I may, in fact, shall I do it now? I will do it now. I think I need to adjust that and get it in the right spot. Let's spin the tool slightly. Let's do a facing cut again. Or just pop myself in the middle. Let's make sure that's adjusted and lock that off. I must have adjusted it or changed the tool or done something, and I've got a, that's quite loose. Let's come in here, just look, see where we are centre wise. Yeah, touch low. Just get it to the right spot and then I'll lock it. I've taken the key out of my tool post. The back key here allows me to swivel the tool around. Okay, let's just have a set a 0 there. Let's have a little cut on there. Yeah, that should be enough. Yeah, a bit of a skin in there. Speed it up a little, now I'm in towards the centre. Well, I can actually see that tool is still a little bit low. Let's try that again. Touch more. A tiny bit more. Yeah, maybe dear me, oh, quite a bit out. That's perfect. Okay. So I'm going to lock that now. Let's get the right Allen key. I think it's that one. It is. Should be another screw around here somewhere. Where are you hiding? Oh, anyway, it's not going anywhere now. Yeah, there it is. So, okay. Right, now that shouldn't go out of adjustment. I'll just get the chamfering tool. In fact, a bit grubby in there. Tool's clean enough. Yeah, it's not often I have a piece of steel or cast iron or material, shall we say, anywhere near this size in the lathe, so nice change. Yeah, just a little 1/2 mil chamfer on there, and I'm going to spin it in the chuck. Okay, so I've flipped it round. You can see where I centre popped it up and then scribed the line, so I've scribed an arc and then milled it down to that spot, and I just use a protractor to put the 120 degrees apart. 3 flats basically to reduce that diameter to make it safer for holding. The back diameter is now smaller. It's okay for holding. It's actually smaller than the size of this, so I need to machine this away now and face this side, and I'll be doing everything from this side to start with then, but again all 50 thou oversize. So I flipped it round, just skim the OD roughly. I now need to turn down a step. It's actually got to be 188 back, but I'm going to do it 160 back to a diameter in the middle here of what's going to be 625. So I'm going to go for 650, let's say, and we're going to step that shoulder back by, let's say, 160 thou. So yeah, straightforward turning. I'm going to do that. It's a roughing operation again. There's going to be an undercut in this space at another point. So yeah, again, just removing material. I'm going to keep the overall thickness the same as drawing. You'll see what I got in mind at a later date. But as I did say, the gear, which is now a timing pulley, is not going to be fixed to the flywheel. It's going to be independent of the flywheel. So yeah, that's my thinking. You'll see when we get somewhere nearer. So yeah, I need to set a 0 on the face, which is where I am. Hang on, now I've set a 0. So I come back 0.188 down to the diameter of what's going to end up being 5/8. So let's try 20 thou passes. Haven't really got the right tool up for this. Shall I swap tools? We'll be alright, it's not a great deal. You know what, I think I'm going to swap tools. We're going to face across that properly rather than use a turning tool. Yeah, do it properly, eh? Why not? I'm taking 40 thou facing cuts. Clattering a bit, it didn't on the last one. Would probably be better. The standard sort of coated tip in now rather than the ground tips I normally use. Where are we? 125 total. 40 to go. Let's get down there somewhere. Haven't done a particular diameter down the bottom there yet. You know, it's probably more like an inch, but I know it's got to be 5/8. We will change tools when we come to do that. But that's a little ways off. So where are we? 120. Let's do a 20 thou pass this time. 140. Okay, let's see if this improves it. Yeah, that's cutting better. Not so much shatter. So just finishing this little spigot down to size. 650 diameter, it's going to finish at 625. I'm just going to aim at 650. And it's 160 thou thick. So I faced it, the main face back at 157. And there's 3 thou left on here to get it to my roughing size. And there's going to be 25 thou left on here to get it to my roughing size. So I'm looking for 650. 661. So yeah, I think just take 5 thou aside off that. Probably do that in one hit. 5 thou aside till my DRO reads 160. That's it. I'm going to set a 0 on depth. Just check the diameter. Again, it's 25 thou up, guys. 648, 647. Yeah, you know, that's fine. Right. So I'm going to do a scratch pass on the base and set a 0 on there. Let's just block that scratch pass. Well, I set that tool on centre earlier, so it is 0 on my DRO, so slow things down again. Okay, and face it down to that 0 on diameter, so go to 160 here, that's 160, probably go a little faster, and just face this. It's only the outside size that's got to run true to that really, because I'm going to be undercutting from probably about this point in, but At least we've got that first step height right. At 160. Again, it is going to be 1875. Should stop cutting here. Yeah, it does. Okay. So what I've determined now is starting diameter there and a starting step height. So big undercut in here. I'll have to go back to my drawing, see how far it comes out. So I've just got a boring bar and I'm roughing this out with a 250 thou undercut. Just running it in at sort of all sorts of jaunty angles. Actually, on reflection, I haven't got a datum. I'm just eyeballing this, so let me just catch a datum because I'm swapping the angles of the bar all the time and I've lost my zero. So if I touch there, set a zero, yeah, I can go in 250 from that pace, and that'll leave me the same amount up as the outer face was. So I'm on 189. Getting close to that boring bar now. I'm just gonna get that at a small area to the depth of 250, and that gives me a reference. That's 240. That's the 250. Okay, I'm starting to foul. Obviously I'm cutting on the backside, running in reverse. So let's come back forwards again now. Straighten the bar out. Oops, slow things down. A little bit of an angle on that bar. So let's pull out from that position where I was, the depth. So there's a small area that in there that's to depth. My OD is very close. Let me just set an OD. Just set a zero where I wish to stop. I'll just stop there for now. Okay, set a zero. Speed wise, maybe a little fast. Zero. So, all this side roughed out, and I know I've got 27 thou on here. So I'm going to flip it round, and I know, obviously, that there's 27 thou, 20 to 30 thou to come off everything on this side at a later date. This side's, had its roughing. So I'm going to flip it round. I'm going to hold it by this inner rim, which I know is running true to this, the roughing on this side. Hold it by that bit, and then it'll give me access to the whole of the outside. And yeah, I mean, that's pretty much the way I'm going to go with it. Turn it round, reverse jaws, hold it inside here, machine everything finished size on the other side. Then when that's done, I may even do the bore, and I may then put the collet up, put a dummy axle in, perhaps put a grub screw through it, or a couple of nice deep grub screws, which again, when I come to the finished part, I've seen it in with roll pins. What I'm going to do is grub screw it and drill into the shaft, basically, and have a point grub screw, like a cone point on the grub screw that actually goes down into the shaft. If it shears, it shears, but it's quick to change. So that's my thinking. And there will be one either side. I could get a roll pin through, but I don't want to drill right through the shaft and risk, changing the shape of the shaft and having it throw in and what have you. which wouldn't look nice. So that's the way I'm going to go. So as it turns out, there's half an inch to come off the thickness of this. So yeah, I'm taking, what, 40 thou passes, and yeah, fairly quick, off it comes. So I finished it to thickness, as you can see. Machined this side completely to sizes. And obviously I left the overall width of the part 27 thou too thick. So all the back faces have all got 27 thou to come off them. And I drilled and reamed the bore while I was at it and finished the OD. So yeah, everything from this side is completely finished, and I just need to flip it round and do the other side. So we've got a few more bits and pieces together now. So flywheel is complete. Obviously it's going to have some more holes in it and what have you. I haven't decided what decoration to do in it yet, but that's for another day. So I am going to go with a timing belt idea. So on the crankshaft end, I've gone for a 20 tooth 2.5mm pitch belt is what we're going to go for. And if you can imagine, on the original drawing there would have been a gear embedded into the flywheel and Loctited in, what have you. There was a counter bore in here, the gear had a shoulder and it pressed down in. So standard pulley, I've reamed it out 8mm, same shaft diameter as the main shaft. I'm going to put some grub screws down through the root of the teeth, probably M3 grub screws, 2 in there at 90 degrees to each other, and that will give me the facility to be able to lock this pulley onto the shaft. And when the flywheel's locked onto the shaft, it's just the same as having the two of them joined together. So as it stands, I think you're in shot here, I can put that in there, and it's, whoops, as you can see, it's a couple of mil too wide. So it's going to need a few mil taken off it, off this space. Not to worry. So I think my next step's going to be put a couple of tapped holes down in here. Nothing special, just chuck it in the vise, put a couple of tapped holes down in for grub screws. I've got some small grub screws. Then we'll look at how much we got to machine off this. I'll probably just pop it on a bit of 8mm shaft in the lathe, fasten it on with the grub screws and throw it on the floor and face it off. So yeah, that's where we're going with that. Okay, what I'm going to do is I'm going to have, instead of having the gears on the back here as it was drawn, with the the lifter on this pivot point here under the valves, I'm going to run another shaft, a cam shaft, down here somewhere. The timing pulley is going to be on this side, so it's easy to access. Obviously you've got there's a cam on the outside of here going on here for the spark timing. But this cam belt will run down from a 20 tooth onto a 40 tooth down here on a shaft. Again, the 40 tooth will be locked to the shaft. The shaft will be on 2 bearings, so I'm going to need another support block here. 2 bearings, I've got some small bearings on order with a 6mm bore. It's going to run on a 6mm shaft, and then obviously the timing belt will be this side and the cam will be this side fastened on the shaft. So as far as timing's concerned, everything can be rotated on the shaft. There's no load on here as such. That thing doesn't want to stay in my hand. No load as such. I'm sure a couple of grub screws. Yeah, I could always do a little spotting in the bottom of the hole just to hold it on the shaft at a later point. Yeah, no problem at all. So I am going with the timing belt and timing pulleys. These are really easy to get hold of online. So this particular one, I forget where I got it from, Simply Bearings I think. So yeah, PBG 16T 2.5 20-2. 20 refers to the amount of teeth. It's running a 6mm belt, this one. So obviously the part number from Simply Bearings would be a 40-2 for the 40 tooth pulley. So that's simple enough. Yeah, let's get on, drill some holes in here, get this space down. The one on the end of this 8mm silver steel, I just polished the burr off. I think it's at this end. Yeah, and that pulley really is a nice fit on there. Yeah, so it will be pinned on at a later stage, but it's coming along nicely. I wonder if we can do a sub-assembly on this. Let's. Don't know, I haven't tried it through the bearings of silver steel. So yeah, it does go together. I haven't got any pins or anything in there yet, and that flywheel runs nice and true anyway. In fact, it's pretty much spot on. I need to get something in there and measure that gap now. That'll give me a good guide as to how big this is going to be. It's not going to fit as it stands, but yeah, that thing doesn't want to stay in my fingers. So yeah, I mean, it's all looking promising anyway. Happy days. I can hear those bearings. I don't think they're the greatest quality in the world, but they'll do the job. And that flywheel is running as sweet as a nut. Happy days. Well, as I usually say, I think that's about it for this one. We're around the 30-minute mark. Since filming that, I've now got two little, I think they're M610 shouldered bearings, M6 bore 10mm OD, MF126ZZ was what they were. Simply bearings they were from. And again, the larger pulley I needed, the 40 size that's going to go on the camshaft. That bearing has arrived, and it pulley, and it does actually have the 6mm hole already in it. So that's brilliant. So that's basically done part of the machining of that for me. So yeah, it's coming along. We've got the bits and bobs, or some more of the bits and bobs. I'll have to work out where the pulleys go to order a timing belt of an appropriate length. I probably won't fix the camshaft in place until I've had a look to see what approximate belts I can get, and then I'll decide on how far apart the two pulleys are. And there's a good chance I'll probably put a tensioner in there on the underside as well, just something with a little swivel where I can put tension on that belt rather than get the lengths exactly right. It'll just make it easier for changing it, or give myself some adjustability for the cam belt. And as we all know, most cam belts in vehicles and what have you have got a tensioner in them, so why not stay with the same idea? So, waffling enough, guys. As per usual, thanks so much for watching. Thanks for subscribing, and we'll see you all very soon. Cheers now.